This is part 2 of section 8.5, which was on alternating series. We have an alternating series here. -1 is to the n plus 1. You should be able to tell if this converges or diverges based on what we've done thus far. Make a decision here real quick if this converges or diverges. In order to check that, what you're doing is you're evaluating the limit as n approaches infinity of the sequence without the alternating part. It does go to 0, so that works. And then also, if I plug in numbers here, 1 over n squared is always decreasing. So this is a convergent series. We are unable to find what this converges to, but what we're working with today is we are finding an inequality that is going to give us two numbers that this is in between. In order to do that, the first thing we are doing is finding the first 4 terms in order to approximate the series. So the first 4 terms, I would plug in 1, gives me 2, so that's positive 1 over 1. And then plug in 2, gives me 3, so it's minus 1 over 4. Plug in 3, gives me plus 1 over 9. Plug in 4, gives me minus 1 over 16. So there's our first 4 terms. So using the first 4 terms to approximate the series, we get whatever that's equal to. Which is 0.799. And then the next question asks, what is the max error of your approximation? In order to talk about how we're going to get this, I'm going to list out a few more values here. So, whoops, not 19, that's a 9. If I were to plug in a bunch of numbers, it would look like this. And so on. We found the first 4 terms. This here is equal to 0.799. And we want to know what's the most that could be off by. So notice for an alternating series, remember these always go down. And it always alternates back and forth between plus, minus, plus, minus. So if this is 0.799 and then I add something to that, and then I take something away that's even smaller than this, and then add back something even smaller, and take away something even smaller, the most it's going to be off, the maximum error, is going to be this very next term. Because I have 0.799 and I go up 1/25th, and then I come back less than that. And then I go up less than that, and back less than that, and up less than that, and so on. The most it could be off is whatever this next term is. So when approximating an alternating series, the max error is the next term. In the sequence. So in this case, our max error is 1 over 25, which is what, 0.04. And then to find an inequality, we know that our sum is in between 0.799 and if I add 1 over 25 and also if I subtract 1 over 25. Because we've added the 1 over 25 here, we know it's between 0.799 and whatever it is when we add. Usually when you write this inequality, you add and subtract, and then you don't have to worry about this sign right here. So we're going to take this plus 1 over 25, 0.839. Also take that minus 1 over 25. 0.759. So we know that the sum of this infinite series is something in between those two values, something around 0.8. This one asks us to approximate the sum by using the first 5 terms. It doesn't explicitly say it, but let's go ahead and write in an inequality that would represent what this sum is approximately equal to. So we want the first 5 terms. Notice we're plugging in 0 first. 1 times 3. 1 factorial is 1. Plugging in 1 gives me minus 3 over 2 factorial. Plus 3 for 3 factorial. Minus. I'm plugging in 3 this time. 4 factorial. Plus 3 over 5 factorial. Find what this is equal to. Uh, 1.9. The max error is going to be the next term. So we plugged in 5 or 4 to get this. So plugging in 5 gives me 3 over technically negative 3. Really max error. We're talking about the absolute value of it because it could be in either direction. 3 over 6 factorial. To get factorial on your calculator, if you're not sure, go to math, scroll over to probability, PRB, and it's right there, number 4. So my max error is 0.0042. So the sum is between 1.9 plus that and 1.9 minus that. Whoops. .896. And that's it for the notes. Homework will be posted to Google Classroom. Enjoy your day.